All right, so I am going to give a little bit of an overview of what the prototype pattern is and how it's used and give a few examples as well. So to start off, you can see that I have listed that prototype is a creational pattern, which means it's used for the creation of objects. The intent of this pattern is to allow the creation of new objects by copying an existing object. And some motivations for this is that it hides and removes complexity of creating nearly identical objects, and it reduces resources and time in object creation. So just a little bit of a conceptual example. If all of these minions here are objects, to create every single attribute of every single one of these may take a very, very long time. And that's where cloning using prototype pattern will make this process much simpler. So for example, we have object one here. Say he's a minion and he's 2 feet tall. He doesn't have any hair. And we want to create this one in the end. However, we don't want to go through every single attribute because many of them are shared. So what we do is we clone object one, which would create object two. And for now, it's identical, but we can also make small modifications. So for example, the height is 2 feet. We'd want to change that to 3 feet. The number of hair is 0 on object one, but we want to have 3 here for number of hairs. However, many of the other attributes that it would have, such as the color being yellow, or the clothing color being blue, or the number of eyes being 2, the number of feet being 2, the number of arms being 2, the color of the shoes being gray, the clothing type is the overalls, that's all the same, and wears glasses is true. So as you can see, a lot of these attributes are shared between the objects. So it wouldn't make sense to go through when we already have one object that has most of these attributes already set up. So that's where we use cloning and the prototype pattern. So the structure of this is that it has a prototype interface class. And this is what will declare the clone method, and it will be implemented by concrete prototypes that will be shown later on. The concrete prototypes are the actual classes that will be creating the objects, and that uses and actually defines what the clone method is, whereas the prototype interface class is just implemented by the concrete prototype. And this represents the specific object being cloned. So in the last example, the concrete prototype would be the minion. The client is the code that requests the creation of a new object. So that's the code that tells when we need to be cloned or when we need to create a new object. But it is not aware of the concrete classes that are involved. The clone method, which is in both the prototype interface class, but actually implemented and defined in the concrete class, will specify the way that the object is cloned. So here is the structure UML diagram here. We see the prototype here is often an abstract class in many cases. So this is the one that declares the clone method and is implemented by concrete prototypes. Can be one, it can be many. So for the concrete prototypes, this is what implements the prototype, and it has the clone method here, but it actually defines what the clone method does. It implements this since this is an abstract class or an interface. So the client is what uses the prototype, but is not aware. You can see that it only uses prototype. It doesn't use any of the concrete prototypes. So it is not aware of the concrete classes that are actually involved, which removes some of that overhead. And the clone method in both the prototype and the concrete class specifies the way that the object would be cloned. So I gave a little bit of an example here. We still have the client. For the prototype class, I have a person prototype, and the two concrete classes are actor and athlete, which are both part of both implement the person prototype. There's a clone method here, and there's a clone for an actor and a clone for an athlete. The clone will obviously be different because there are different attributes that need to be cloned. And this is going to be a very simple example since it wouldn't make sense to have a bunch of attributes in this example. So say, for example, in the case of the actors, that there are numerous actors that have the role of villain. That's their role, and the genre is action movie. So creating one villain, an action movie actor with those attributes, and cloning it for all the others will save lots of time, especially if there are hundreds that are villains in that action movie, and you can modify the name or any other attributes that there are. Another example is if we had a simple sports game, simulator game, I guess you could say, and we had a bunch of athletes. Say, for example, that we have 30 hockey teams in this game. They each have two defensemen. So if you create one athlete with position defense and sport hockey, you can clone the rest for the other instances on the 30 teams that each have two of that exact person that we are creating for the class. So, like I said, both of these are very basic examples. And if these classes had many more attributes, such as like 50 or more attributes, that would take a lot more time to create manually. That's when using the prototype pattern would actually come into play, and cloning would make it a lot easier. So if we had a complex example, say we were still using the athlete, but they had over 50 attributes that had all of the stats and ratings. Like, for example, they had a speed rating and a strength rating and an agility rating, so on. In a very similar example, we could have position, defense, sport, hockey, and usually the people who play defense and hockey have very, very similar stats. So creating all those 50 stats for one athlete and then cloning that would be much easier than creating 100 individual athletes that all have almost identical stats. And like I said, after the clone happens, we can modify the objects that are cloned. So some of the advantages of this prototype pattern is that it reduces most of the object creation costs and overhead. This is specifically noticed when the objects are very similar and have slight differences. It also simplifies object creation by cloning objects that may be similar. So, like the first point, the objects will be created based on cloning from another object, which will reduce the overhead of and the complexity of going through every single attribute and creating that and copying that over. So some of the disadvantages is that it can overcomplicate simple object creation processes. Like in the example before, those were pretty simple and wouldn't take too much to uh, just copy each individual attribute rather than cloning the person or creating everything manually. Another disadvantage is that deep copying can be an issue if that is done incorrectly using the clone. So some known uses or examples is now the first one here we have that templates or formatting for documents or files. If formatting can be preserved when creating a new document that will have a similar format by cloning the format. So if a specific document type has a very specific formatting with a bunch of different attributes based on size and font and setup and things like that, cloning that can create a very similar document when all you need to do is adjust the body or the headers or titles. The second one here is GUI elements in applications. Many elements in applications will share similar or identical configurations, such as size, color, and styling, and therefore can be prototyped so you don't have to create everything over and over and over again when you just have one that you can clone from. Third is software development configuration cloning. Application configurations can be cloned and slightly altered for development or testing purposes. If there are specific configurations that need to be used, say for a testing environment, we can clone that and maybe modify it slightly if there's a slight change that needs to be done for testing or development. And lastly, we have game development object cloning. Similar to the example that I gave with the athletes and actors, games often need multiple instances of the same items or characters. And some may need slight altering, but overall, if you have 100 characters that are all almost identical, maybe have a slight difference in one number, cloning can be very, very helpful for that. Or if you have specific objects that are almost identical or are identical, cloning would be very useful for that. So when to use? Um, it's very useful when you have many nearly identical objects. which may have slight variations, as we have seen in past examples. Another time to use this is when brand new objects are pretty costly to create, and we can reduce some of that overhead by cloning it, especially if they're nearly identical. And lastly here, when cloning objects is faster than creating from scratch. A lot of times, if we have many attributes and they're going to be very similar, cloning the object will be the fastest way rather than manually going through and setting all the attributes with a constructor. When not to use. When there are very few variations in objects, a lot of times subclasses can be used instead, and that's a more manageable way to do it, especially since we won't be cloning and having numerous variations of objects. The second one is when most objects are going to be unique. If most objects are going to be unique, then there really is no reason to clone objects or have the ability to clone objects, because it's just going to be more steps and more complex to clone and then change everything rather than just creating them from scratch. And lastly, when objects are simpler and fast to create, there's really no need for cloning, since cloning will reduce if it's complex. So when objects are simple and fast to create, then there's no need to use the prototype pattern, because it'll be simpler just to do it manually. So in my example program here, I created, similar to the example that we had before, a simple sports game calculator, or sports game simulator rather. So the client implements the create a person, and the person prototype is an abstract class, which is implemented by the concrete class athlete, so that athletes can be created and cloned using the client code, which will create a person by cloning. You can also see that display and modify are also implemented by the athlete class from the prototype, the person prototype abstract class that I will display here. In addition to that, more concrete classes could be added. For example, if we wanted to add an actor to the person prototype, we can also do that, because it will be very similar to what the athlete is doing, but it will be a different class that can implement the person prototype. So the person prototype, the image on the left, this is the abstract class, and you can see there are three methods that are public: the clone method, the display method, and the modify method. So we will focus on the modify method, or sorry, we will focus on the clone method, since that is how the prototype pattern is used. So you can see all these different attributes that we have here. We have the name, position, sport, speed rating, strength rating, and stamina rating. And so we have the constructor here. So what the clone does is it will create a new athlete by copying all of the existing attributes, such as name, position, sport, speed rating, strength rating, stamina rating, and it will create a new athlete based on that and return that new athlete, so that the client code can create a new object based on that. And I have a print statement just to display here how that works. In addition to that, I have a display method to display an athlete for testing purposes. And lastly, we have the modify function, which is not entirely visible here because it has a long implementation and it would take up a lot of the screen. But that will basically gives you the opportunity to change any of these after the fact, after it's cloned, and that will be seen in the next slide. So I have the client code as a function. So what this will do is it's a function called create, which takes in a person prototype and will clone that and return the cloned object. So this calls the clone for the person prototype, which is the abstract class, but implemented by the concrete class. And so this is another function which takes in a vector of person prototypes. So this will simulate a team. So I have this set up as clone and modify team. So if we have a vector of a team, which I'll show you in the next image over here, it will go through every team or go through every member of the team, and it will go through, create a new team here, and it will push back or add one, calling this create function that creates based on the current team that is brought in. So creating team I, team in position I, will take the person prototype or athlete in this case from the team in this position I in the loop, and it will call the create function, which will call the clone function for the person prototype, and not have to use any of the, not have to know what concrete class it is. And then it will display, and this will be displayed in the output. So for example, we have 4 athletes here that will be prototyped. We have a hockey defenseman, a hockey forward, a hockey center, and a hockey goalie. And their ratings are all going to be very similar because centers all have very similar ratings based on their sport and their position. So I create 4-person prototypes that will use the create function here and clone these objects. And then I'll create team 1, which will push back person 1 twice. So it'll be 2 of the defensemen, push back person 2 twice, 2 forwards, push back person 3 once, 1 center, and 1 goalie. So for now, all of these people have no names, which is really what you would want to change if you're creating a bunch of teams. All these people have no names, so we can go through and modify that. So first, we're going to display the team. I'll show you the output on the next slide. We're going to display the team, which should show no name hockey defenseman, no name hockey defenseman, then the forward, then the other forward, then the center, then the goalie. And it will display all of those because that is what is included in team 1. So we then create a vector of person prototypes called team 2. And this will call the clone and modify team. So going back over here, this will take every person prototype that is in team, and it will create, which will clone it. It will create a new object. And then after that, it will go through and ask if you want to modify after each individual object is cloned, then it will go through and ask if you want to modify it, which will give you the option to change any of the features that is implemented in the concrete class athlete. So here is the output. The team of prototypes that I created, let me go back one slide. The team of prototypes is team 1, and team 2 is the team that clones these, and then I'll go through and change every name to show that the names can be changed, and maybe and a different attribute, such as one of these ratings here. So we have the 2 defensemen that I mentioned from the prototypes. We have the 2 forward that I mentioned from the prototype, and 1 center and 1 goalie. So then when I clone this team, it went through and it cloned all these objects by using the client code, the client function create. And then I modified and just changed the name defense 1, defense 2, forward 1, forward 2, the only center and the only goalie. And I also changed the stamina of this final one just to display that these can be created and modified. So the purpose for this is, rather than going through and creating 1, 2, 3, 4, 5, 6, 7 times 6 different times that the user is being asked to enter a specific attribute for these, we clone this and then we modify 1, 2, 3, 4, 5, 6, 7. We only modify 7 different attributes, which is very useful because all these other attributes will be very similar, especially since forwards will have very similar attributes to other forwards, and these can all be modified later. So this can be very useful if you had 30 teams and you wanted to clone one team that already has all this set up, and maybe you want to change the name, and you can enter in 7 attributes for every single person on every single 7 or 6 players on 7 attributes for all 6 team members for all 30 teams. You can see that the amount of steps will definitely add up, which is why cloning will make a lot of sense in this case, and it reduces the steps that are It reduces the steps for creating objects that are very similar. All right, and that is the end of my presentation, and I have a couple of links here that display more in depth what the prototype pattern is and how it is used. Thank you very much.